Hello, this is Joseph Cambrakis. I'm recording a demonstration of decision trees in Apache Spark. This demonstration is for Databricks, and I'll be using the Databricks Community Edition environment for the demo. Our first step is going to be to load in our required libraries. We're going to need the decision tree library from MLlib, and then we're also going to need some helper functions, label point and string encoder. So we'll load those in. Then we'll look at loading our data. Our data has been preloaded in our data tab, and I have a photo of it here. The data set is South African heart disease data. It comes from elements of statistical learning. We'll examine that data in the following steps. So to load it, we're going to do a read CSV and create a data frame called raw data, and the header is the labels in this case. So let's start to examine our data. We have a nice helper function called 2pandas that will print out our data frame. So here we see a printout of our data. We see the columns are at the top, and these are all health related. We have blood pressure, tobacco use, cholesterol, family history, type A diabetes, obesity, alcohol use, age, and then our target variable, chronic heart disease, which is represented as a 1 or a 0. 1 represents has heart disease, 0 represents doesn't have heart disease. So let's look at the schema of our data. So we see our schema. All our variables are strings, but when we looked at it in that pandas data frame, we saw that we actually had a lot of numbers. So part of our data cleaning is going to be to cast these strings appropriately as integers and floats. So to do that, we're going to take our data frame, raw data, and then use the with column method, which is going to take a column and then create a casting of it. So we're going to take raw data, systolic blood pressure, and cast it as a float. And then we'll repeat that process, chaining these methods for tobacco, cholesterol, type A diabetes, obesity, alcohol, and so on. Then we'll print that schema out to make sure that our data is changed appropriately. We also had one variable that was categorical, family history. If we look back at our data frame, we see it's present or absent. This we're not going to be able to cast as an int or a float. We're going to have to cast it as categorical. We have a helper function called string indexer that's going to do that for us. So we're going to input family history. We're going to output family history index. What that's going to do is create a dummy variable or an indicator variable for us. So we'll run this and then look at our schema. So now we see that we have floats and integers. And if we look down after we do our indexing, we now see we have family history as a dummy variable, a 1 or a 0. And it's encoded as a double in this case. We're going to need to do some more data cleaning. Our model, because we're using the MLlib library, requires an RDD. So we're going to have to change our data frame into an RDD. We'll do that with the .rdd method. Then we're going to just select the particular variables we want. So we want heart disease, and then the other indicator variables. We can drop family history because we now have that dummy variable, family history index. Another requirement of our function is that the data is in the labeled point format. What this means is that there's two parts to our data. There's the indicator, the target variable, chronic heart disease, and then an array of indicator variables or inputs. So we'll transform our data into label point, or map our data into label point, and then we'll print out the first one just to get an idea of what it looks like. So we have our first row, our indicator, chronic heart disease, and then we have an array of other variables. So let's build our decision tree. We'll create a model object, and we'll use our decision tree library that we loaded at the beginning. And that has a method called trainClassifier. It's going to take our data that we just created, data 3, our label point RDD. It's going to also take some other arguments, the number of classes. So we have 2 classes, chronic heart disease, no chronic heart disease. We're also going to need to tell it what categorical features there are. And in this case, we don't need to because we transformed our data into dummy variables. We need a splitting metric, which is going to be Ginny. We're going to define our tree depth, and then the number of bins for our variables. Then we're going to print our model out. So we trained our model. Let's print it. And we need one more set of parentheses on print to debug string. So there we have our model. We have a decision tree classifier with a depth of 3, as we defined in our max depths. And we see if feature 7 less than or equal to 49, if feature 7 less than or equal to 28, if it's not very interpretable. We have a lot of feature and not very clear what's going on. We see we have some predictions, predict 0, predict 1, but this isn't very helpful. So let's define a helper function here that's going to take our model and then replace all those features with actual column names. Now we see what the variables actually are. If obesity is less than 49, we'll predict healthy. If we have high blood pressure, we're going to predict heart disease. Else, if tobacco use is high, predict heart disease. So we see we have a slightly easier to interpret tree in this example. Let's check our model accuracy. So what we're going to do is take our model and build predictions out of it using the predict method. Then we'll create this predict. We're going to join that with our data. And then we are going to create errors, or measure our errors, which is going to be just when our prediction doesn't match our actual value, our actual label, our 1 or a 0. We're going to count those up, and when they don't match, that's going to be an error. And we're going to divide that by the total number of rows with a count. So we see our error rate is about 26%, which means that we're pretty accurate. We're accurate about 74% of the time. So let's try to build another model that has some different features. So we'll build a new model. And we're going to give it more trees and more bins. So we'll do a max depth of 13. So a much deeper tree, and we're going to have many more bins. And this is going to give us overfitting, because we're asking many, many, many questions and building a very complex model on top of our training set that is going to contort exactly to our training set. So we'll build it and print our error. And we get an error of 0. And this is because we've overfit our model to match our training set exactly. Let's try printing our label, printing our model out. We'll use that code again and see just how complex a model we've built. So we have 217 nodes with a depth of 13. And we see we have all these if features. And it goes and it goes. And this is a very, very complex model that's going to contort and match every single data point. Thank you.